Okay. So we have this question says a ladder is 25 feet long, leaning against the wall of a house. See the base of ladder is pulling away at a foot of 2 feet per second. Now, why I emphasize the ladder question? Because there's so many variation you can do to the ladder situations. Um, in real life, the question could be much harder. Um, I have a question that is a guy is dropping a ball, dropping a rock from a parachute that's going up at a certain speed, and then I drop in the parachute at this height, and we want to find out how fast the shadow is moving. The shadow, not a rock, not a rock. The shadow, how fast the shadow is moving. I usually give out those questions to my most willing challenge student, like who think that they can challenge and accept the challenge and overcome it. I have people in the past solve it with the ease. So and you can have a very strange question on those related rate. It's very interesting. Um, so interesting for me, but it doesn't mean it's interesting for you. I know. So let's talk about the first question. The first question we did it very quickly. But anyway, the first question basically just a ladder question, and this is 25. This is pointing away. This is x. This is y, and dx dt is equal to 2. And we're trying to find the dy dt when x is equal to 7. So 7 is temporary, it's not a constant. 7 is changing. So therefore, you just have to go in and solve the problem. You're going to say x squared plus y squared equal to 25 squared. If you take d to the dt, it's going to be 2x dx dt plus 2y dy dt. And remember, constant is your BFF. If you have best friend in calculus, his name is going to be constant. Okay? 0. Because derivative of 25 is equal to 0. The ladder doesn't have a change, the speed of change. The ladder stay the same. So once ladder stay the same, guess what? They are always going to take a derivative is always going to be 0. So 2 times 7 dx dt is 2 plus 2y, which is we can evaluate by using the Pythagorean identities. And then y squared equal to 576. Y is equal to 24 plus minus. So this one is 24, and dy dt is going to be right here. And if you solve for it, guess what? It's going to get 48 dy dt is equal to negative 28. If you move 28 to the other side, dy dt is equal to negative 28 over 48, which is equal to negative 7 over 12. And that's where we find dy dt yesterday. Now you're supposed to find it for 15 feet, 24 feet from the wall. You're going to find out they are different speed dy dt. We talk about it. When dy dt dropping down, they are various throughout the whole time, depending on proportion of the triangle. Anyway, that's A. So let's talk about B. They say consider the triangle form. So this is a triangle that's formed between this, right? And they say the ladder of the ground, find the rate of which area of triangle is changing with the base of ladder 7 feet. So this still stay at 7. You don't need to find out 15 and 24. You just find out that's a 7. And we want to see how much the triangle. Now, this has no application to anything. Why would we want to find a triangle inside of a ladder? It has no purpose of anything. This purely just hypothetical situations. So we want you to figure out what that is, right? Any ideas? We want to find out how fast the area is changing inside this triangle. So any ideas? Yep. For example, question 3. Yes, Ethan?
Wouldn't you just, couldn't you, since like y is going to be the same, since x didn't change, it's still going to be equal to 24, and then you can just do the derivative of the area of a triangle, which is just dA over dt equals 1/2, and then just do like the product rule for base times height.
Yep, perfect. So base times height is going to be x times y, right?
Yeah.
So dA dt, and just like what we did yesterday on question 3, so that's going to be x dy dt plus y dx dt. So there's a product mode because those are two variables. And then once you're done, so it's going to be 1/2. Well, we know this is 7. We know dy dt is, well, dy dt we already have, which is nice. dy dt is going to install it from here, which is, we know that is the same. So this one's actually a little bit harder because you had to use all the information from before, and a plus y, which is, I don't know, y is 24, right? And dx dt is 2. Now, I'm not worried about solving this part, and I'm not going to spend time solving it, but that's the solutions. You can solve it if you want, but you don't have to. This part, I know you know how to work out with fractions, hopefully. I mean, if you don't, I still can teach you, but I don't want to spend time over that. Now we're going to talk about final question, which is kind of difficult on this question. I think most of the fear is always around when they give you the d angle dt. So can I erase this? It's okay? Okay. So I'm going to erase it. So, oops. That's not what I want. Delete. Now we're gonna say find the rate angle changing between the ladder and the wall. The house is changing when the base of the ladder is 7. So what does that mean, right? What does that mean? So let's draw the same picture again. And so I'm gonna draw a ladder again. And you're gonna say, why does this ladder look different? Well, I just really think about, I had to go by the scales. So this is 25, this is 7 still. Let's ask a question. What is a constant in this case? 25. Is the 7 changing?
It changed.
Yeah, it's changing. So we cannot use 7 for sure. We can use 7 when we deal with condition, which is after you take a derivative. Does that make sense? So what the question is asking, they say find the rate with angle between the ladder and the wall. So remember, usually I assign variable, right? X, Y. What else I need to assign here? Yes.
Wouldn't it be the angle
Between
between like
Y and 25. Good. Between the wall and the thing. So I'm going to use a different color coding here. It's going to be right here. Now, this angles on the top, it's very important you understand the opposite becomes the bottom. Because usually we replace the angle on the bottom if we're doing the right triangle problem. But I can assign the angle to be on the top. If it's on the top, the opposite is actually the bottom. Does that make sense? Okay. So now we say constant is your friend. So also pay attention. If they ever ask this angle, rate changing, that means d theta dt. If something d theta dt, usually is result to SOHCAHTOA. There's no other way around it. BFF is a constant. If I have a kid, I'll name it constant. And people are going to ask me why, because of calculus. Constant is not a bad name, though. That sounds really horrible. That sounds really bad. Constant, yeah, that sounds really bad. It has to, at the end, you have to fit last name, yeah. So constant. So constant is gonna be on the denominator. On denominator in this case. Why a constant you want to arrange the denominator? Well, there's a reason for that. We're gonna show you in a second. Now, SOHCAHTOA. Which trig function I will use where constants on the bottom? What is the constant again? 25, the ladder length. Which one has a constant on the bottom? Sine and cosine. Now, the next question is, which one's a better choice? So sine and cosine, which one's a better choice? Why cosine? Why sine? And what do you think the reason is? Okay, does anybody suggest sine? Nobody? Just because Katie says so doesn't mean that's true. Yes.
Could you use sine because when you take the derivative, it's going to be. If you're trying to use cosine, it would be like negative sine kind of because you have to take the derivative. No.
Yeah, okay, so that's another reason, but that won't be the reason I would depend on. Here's why. Remember, if I have opposite, I would use sine. Here's what the reason being. If I have a sine of data, right, I will have something over 25. Does that make sense? Yeah. I have x, right? Yeah. Now, if I have a cosine of data, that's going to be y over 25. Yeah. Now, if I take a derivative of y, I get dy dt, which is not like I don't have. But what if I evaluate my dy dt wrong? So I always use the one that is given to me instead of the dy dt, because what if I got dy dt? The dy dt I got from before, I think is a negative 7 over 12. Now what if I got 7 over 12? Then I'm pretty much screwed there. It's possible you guys get wrong sign all the time. So use something more reliable source, that's me. The me is reliable source is going to be dx dt, and dx dt is more reliable because that's given. Does that make sense? Okay, so this one is not the way to go. Then I will say that's take a derivative of this. And then that's going to be cosine of data, d data dt, equal to 1 over 25 dx dt. And then d data dt is equal to 1 over 25. Now, here's the reason why you want this on the bottom. Because if you use the cosecant, you say, I will try to be cube. Well, why not? But you get 25 over x. It's much harder to take a derivative of 25 over x rather than 1 over 25x. By the way, you don't use your quotient rule here. You just use something called constant multiple. Because 1 over 25 take outside, just take the derivative of x. Then it's going on 25 dx dt. Am I going too fast? Yes, hold on.
Is it 1 or is it 7?
It's 1.
Is your x 7?
No. The x is constantly changing. We don't need that because we just take a derivative of the x over 25. So we're not doing that. We just take a derivative and then we can plug in. But we're going to use 7. After we take a derivative, then you can use the 7. Because that's a condition. If the latter is 7 feet away, that's if, right? It could be 8, could be 9, could be 10. So it really depends on what is common.
What happens to dx over dt?
I'm going to write it down dx dt, which is 2, right? And the cosine data is going to be the other side. So it's 1 over cosecant. Oh, no, 1 over secant data, right? No, sorry. It's going to be 1 over cosine data. 1 over cosine data because you divided by both sides by cosine. Now that's going to be 2 over 25. And then cosine is going to be secant data. You guys know what the secant data, right? Is equal to hypotenuse over adjacent. So 2 over 25 times hypotenuse is 25. Adjacent is what? 24. So 25 cancel out. That's 1 over 12 radian per second. And you're like, oh, wow, that's not bad. Now, how about you practice it? Any question before I move on? I know this is a very challenged thinking. It's a very, very different than what you did before. 2 over 25 times 25 over 24, so 25 cancel out. And then I'll reduce it down to 1 over 12 radian per second. That means I change, you guys didn't know radian. 1 radian is roughly 56.7 degrees. So 1/12 of that is going to be 57 times 1/12 of that, which is roughly 5 degrees per second. Well, you should know, dude. I understand the realistic situation. So the reason why it's 1 radian is equal to 57.3 degrees is because 180 degree is equal to pi radians. So then it's 180 divided by pi. So roughly 57 degrees. So if you understand that radian per second, you more understand that it's only changing angle 5 degrees per second. So that is more relevant. So because it's really hard to grasp what it means 1 over 12 radian, right? 1 over 12 radian doesn't mean anything to you. But if I change 5 degrees per second, that kind of makes sure I understand it a little bit better. Because usually you cannot tell what is radians. Okay. So here's a question for you. So don't worry about the bottom. And we just only want to do B. We only want to do B. We don't want to do A. There's a reason why I don't want you to do A. It's not like I don't want you to do them. It's because that's not a goal today. On your homework, you don't have to do A. But the goal is to be able to do d theta dt, d theta dt today. They draw out a picture for you, which is nice. I don't even draw out a picture. Caroline, you can do this. What kind of martial art you do again? What kind of martial art you doing again? Jiu-jitsu? Yeah. Just think about this as an opponent. You're gonna kick his ass. You have to have that mindset. You cannot beat, oh my god, he's so big. I cannot beat him. I see the fear in your eye.
Really?
You don't need a calculator with this. Good job. No, that's the things that you have to see. Like, if it's a calculator, I will tell you use a calculator. Like last question yesterday, yeah, 78.1. You need a calculator with that. Draw out a picture, write down the informations. Think about you want to set up a SOHCAHTOA with the constants on the bottom, but the constant in this case a little bit different. So hopefully you can see that. guys can talk to each other too. Okay, so I'm gonna do it really quickly. So it's gonna be this is 3,000, right? And this is a 4,000 temporary, and it's going up at 800 feet per second. I should have paid attention to the time. I'm so sorry, but I will use tangent here. Why I will use tangent? Because the 3,000 is on the bottom is a constant. This one don't change. This is a constant. And this is a y is changing, so that's going to be secant theta d theta dt is equal to 1 over 3,000, and then dy dt, which is 800, so it'll be 1 over 3,000 times 800 times, this is secant square, so that is divided by both sides by secant square, so the cosine square theta, and then that's going to be 8 over 30, so it'd be 4 over 15 times by cosine square theta. It's 3, 4, 5 triangle. So the 5 is on the bottom, and adjacent is what? Adjacent is 3, right? Square. So it's going to be 4 over 15 times 9 over 25. And this one is going to be 3. This one's going to be 5. So it'll be 125, 12 radian per second.